All right, guys, welcome back. This is the second video in the modeling session that we are doing, our series. These are all going to be online now as much as I can pump them out here for you. Makes it more convenient for you. You can revisit it later if you're unclear on certain concepts. You might have a different takeaway the second time around, or if you just really don't like me talking or my speed, you can just fast forward it, put it on mute, skip over whatever it is, as long as you understand the concepts that we're getting at, have a clear introduction to it. That's great, and take it at your own course here. So, without further ado, let's jump into it. Let's jump into it. Let's jump into it. There we go. So what we're going to cover in this series today, or this lecture, we're going to cover some basic functions. So if you have had an introduction to Excel whatsoever and you know the ins and outs of it, this is going to be a very rudimentary repeat for you. So feel free to skip over that, but it's going to just talk about some basic functions really quickly. Statistical functions we'll jump into next. That's nothing too new. It's not too advanced either, so you guys aren't going to be scratching your heads, and if you are, then get that itch looked at. But we're not going out of the so to say introductory or beginner stage today, just because we don't want to lose anyone. We're trying to get core concepts built in, and then we're going to kind of steer the ship into deeper waters, so to say, and get into those advanced topics and advanced concepts. So don't worry, they're coming. I promise you, if you're bored out of your mind, there's going to be a time where you're wishing we could go back to things like this. So take it with a grain of salt, enjoy it while it lasts, and without wasting any more time, let's keep going. I'll jump into a couple examples today just to make sure that points are solidified, that they're concrete, that you guys understand the ins and outs of them, that there's nothing left on the table as far as maybe questions go. I know I'm not going to answer everything, or I might say something incorrectly, so please correct me, leave a comment, leave a question, whatever it might be, a trailing thought, something not even relevant to this, just dump it into the comment section, and we'll have an open public discussion there. Hopefully that's something more productive than it is distracting, and we'll maybe have to revisit if those are just open discussion board or not. Moving forward, conditional statements. So if you don't know what those are, don't worry. We're going to cover ins and outs of that, and then run it home here with a if statement example. So that's another Excel sheet example. And then we'll touch on running a lottery. Just kind of take a break from introduction, look at what you can do with Excel. Very rough introduction to if you were to run a lottery, what would happen if you set it up incorrectly, how you could take advantage of it, how you could prevent being taken advantage of, how you would optimize it, and really just cover ins and outs of what you could do if you yourself ran a lottery. So we'll look at that. We'll talk maybe about a real case study that occurred with people. No, I don't live at an airport. Just so happens to be an airplane flying overhead. I don't know if you can hear it. If you can't, then it's just like I'm talking to myself. I'm hearing things. That's also troublesome, and I promise you that's not what's going on either. Continuing forward, we're going to introduce the homework number 2. So if you're following along with the course material as well, in addition with these series videos, then great. You're going to have your work cut out with you with that assignment. It's not too difficult, but it does take you to push yourself a little bit further than the first assignment. And then once again, if you're watching live or you're in class, then you get to join me for those enjoyable a few minutes after this session where we jump into office hours, and we're going to be talking about our business book club and the book that we're going through at the moment. Moving forward, jumping straight into functions. So let's just throw them all up there. Got 4 functions I want to introduce very quickly, starting off with sum. Sum just takes a range of values. It can be an array, or you can be comma delimited values. And really, just to break it down in simplistic ways, it's doing exactly as it states that it is going to do. It's going to take all those values and summate them. It's going to sum them. It's going to add them all up against each other and give you that result. Okay? Nothing out of the water as far as confusing or difficult with that, hopefully. Nothing out of the blue. It's just, it is as it says it is. It's going to be summing those numbers from, your range or whatever you specify, okay? And we'll look at examples. So if you're not someone who likes to just look at text on a screen, I know I'm not. Don't worry, we're going to be looking at examples which show these things, but we're going to move quickly. I don't want this to be a very long video because it's not necessary for it to be too long. We'll take time when we need to, but other than that, I'm going to fly through. You guys can slow it down. You guys can pause it. You guys can do what you need to do. I'm just going to introduce it and we're going to keep moving. Okay, so moving on, we have Sumproduct. And so what this is going to do is it's going to take two arrays, or just follow along here. It's going to take two ranges. And so what this means is that you're going to have one range or one array, and then a second range, your second array, we'll call array 1, array 2, just for simplicity. And so item 0 in array 1 will be multiplied against item 0 from array 2, and then we'll set that value aside. We'll then look on at the next pair of values, which in this case will be item 1, array 1, item 1, array 2. We'll multiply those together, get the product, and set that value aside, and so forth until we're no longer having to deal with any more pairs, or we've reached the size of our range, or that endpoint of our range. Okay, so once we have all of those products set aside as values, then we're going to sum all of those together, and thus it's called Sumproduct. So if you ever get lost, sometimes the phrasing or the term or the function that you're actually using can help explain to you what it does. Also, it's very nice in Google Sheets. You'll see as we explore deeper that the actual helper functions are going to be right there next to them as well. So there's no need to ever fret or freak out, because you always have a solution or a helper cheat sheet right there next to you. So if you are lost or you're having one of those brain fart moments, you can quickly recover or teach yourself really quickly from an example, or by rereading the actual commentary or use case examples provided by Google in this case. Okay, so the next one we have here is min. So this minimum function, it takes an array as well, and just like the name states, it's going to return the lowest value or the minimum value in that range. Same kind of thing we're going to see there with the max function. It's going to return that maximum value in the range. Now, one thing I do want to note is that Google Sheets has an entire function list with examples and how to use these functions online. So this is just a link that will take you exactly to Google Sheet function list. You can Google that. It'll pop up. It's not hidden. I'm not the only one in the world with access. If you ever need anything, type it in here. It'll show you the name of it. That's what you're going to put right after that equal sign. You're going to have the syntax and what it takes. So it shows, like, let's type in, one of the ones we just talked about, Sumproduct. Okay, here it is. It tells you that it returns, or it takes in an array. It's called Sumproduct. It shows you the syntax. It'll be Sumproduct and then an array. And then separated by a comma and another array, and it looks like it could even take additional arrays. It gives you a short little description. So pretty self-explanatory as far as how this can go and help you. You can even click more. This will take you, I think, to show you some examples. It'll show you some examples of the use cases with formulas and whatnot. So very powerful stuff. So if there's ever anything that's lacking on my end and you want to see some additional examples, or just have someone from Google explain it to you, just jump right onto this help document here, and you can populate any kind of example you want to see. Let's type in a different typeset. So we can say math, and all of these additional functions that you might use for math-based calculations or math processing or any kind of value operations. You could look and see that there's many different types of examples here of formulas that you would find beneficial. Okay, you don't know what they do, just look at it. Say I think I want to find an average of some subset or some range, but I don't know what that function might be. Well, let's just type in average. Is that not averager, but average? Sorry, the headphone line was getting in the way there. Yes, I am using wired headphones, just so I think it's more clear. If you guys can't hear me on the audio side, apologies. I'm just trying to get up to speed on all of this. So hopefully this is working well. We might have to change things up in the later series, but yeah. Okay, so Just type in average, and very quickly you'll see, there's a few different averages I could use here. But I just want to average a range of values. So let's see, statistical. This is probably the one I want. It's literally called average. What does it do? It takes a value, takes two values, it could take a range, returns the numerical average value in a data set ignoring text. Perfect. That's all I need. So I'm going to use that one. So that's how you could utilize this. Once again, you just type this into Google and Google Sheets function list. But it's very powerful. All right, let's get back to it. Minimum array, perfect. So we covered everything here. Statistical functions. I'm just going to jump through these very quickly. We have the average. I just talked about that. It's just going to return the average of the provided array. In this case, your provided range or your set of values. Okay, so I just want to use terminology. We're going to go to a single term. I'm just going to be using array in the future, but right now, just so you guys can feel as though this information is sticking and that you understand the words in common terms. Array, once again, is just the range of values you're selecting. Okay, very good. Standard deviation. So another strong statistical function that you'll be utilizing very often, so don't shy away from it. I'm using .p to show that it's the entire population or the entire data set. So there's a simple but important difference, and I think the word I was looking for was significant difference. So there's a significant difference of using that .p. Okay, we do want to utilize this. There's some cases where we won't, but for the most part, just use the .p. Okay, and it's going to show you the relevancy, or does this data really have meaning in the subsect or in our results? Does it really hold meaning as far as what it's communicating? Just like standard deviation in any of your other science classes. So you'll use it the same way. Mode is just going to show you the most often or the most occurring value in that data set. Okay? We all know that stuff. We won't cover it too much more. See it in action. Let's go to it. Okay. So right here we have, very quickly, let's make this a little bit bigger so we can see it clearly. Don't want you guys squinting at the screen too much. So just looking at the data, we don't really have any information about what we're looking at, so we need to interpret it. We see there's unit A, there's unit B, there's price A, price B. Okay. It looks like it's weekly sales for two products at two different prices. Let's look at the prices. Okay, we see the prices change here. All right. How much do they change by? Is this important? It gets bumped up by $10 each. All right. Nothing significant there. We're calculating total revenue of the two products together, 525, 356, etc. We have a sales total. So we have a pretty clear idea of what's going on. We're selling two products, we're collecting revenue, and we're going to operate on those data values or on this data set. So let's see what's going on. Okay, so let's look at what's going on up here. We're just using operators manually. We're not actually taking the data and wrapping it into a formula, so to say. You can tell that because we just have an equal sign and there's no text anywhere with parentheses. So we're operating on the cell values. Yes, we didn't type in the information, but we're just operating on the cell value. So looking across, we're just taking the price of unit A and we're multiplying it to the to the volume of unit A. So volume or quantity times price equals revenue in this case. This is sales price to specify. Okay, and then secondly, we're adding that together with what should be and is in this case correctly done, our price of unit B times the volume or quantity of unit B. Great. Okay, very simple. That's how we're calculating revenue. Let's see. Here's an example of the use case of sum. So instead of adding these all together in our head, we're just using the function right here as specified with the equal sign, then typing sum, putting the parenthesis, and then selecting that range. So let's write it out so we can see it being used. We wrote equals sum. I put that parenthesis, highlighted my range, close the parenthesis, and hit enter. Very easy, nothing complex. Moving on. Sales total now. Okay, so we are looking at something a little more complex here, because what we want to do is we want to take all of these and we want to summate them. But what we're looking at is, if we didn't calculate total revenue for each week, how can we just get the sales total over this entire period of time? Once again, without this column here. So let's hide that for the moment and say, how would we calculate this? Well, we'd use a Sumproduct function, taking this unit array. Yes, it's spanning 2 columns, but we would take this as one array, but a comma, and then take our pricing function or pricing data as the second array. Okay, so let's open this up and see exactly how it's done. Sumproduct will highlight that first array we want to look at, put the comma, highlight the second array we want to look at, and now what's happening is we're having unit A multiplied against price A, and then unit B multiplied against price B, and then we're summing those values, the product values of this specific row together, and holding on to that value. As we move on to operate on this row, where we're saying unit A times price A plus unit B times price B, sum. Hold that value. And at the very end, when we have calculated all these values, it sums those together. So in a half second, it's calculating all of these values over here, which was all of our total revenue by a weekly basis, and it's calculating it over the entire period. Very good. And then looking at, let's see, average, we just calculated the average, and we'll open this up and take a look at it, typed in average, and then selected our actual range or the array we want to look at. Okay, same goes for over here for unit B. We selected unit B's range and wrote average as the function. For min, we wrote min, selected our range or our array, that's a fun one to say, and we did the same here. And it spits out that we have weeks that are reflecting 0. Okay, we did the same for max. Let's open it up so you guys can see it. Max and our range, and once again reflected that as 6. Standard deviation, we wrote stdev.p. Remember that .p specifier, and then parentheses in our range. Okay, so for the standard deviation for this range or this array or this data set of unit A, so 1.89. For this range, we have 1.5. Okay. I gave an example of how arrays work. You guys can stop and take a look at it if it helps you. If you want to open this up, I'm showcasing that this 64 is, the numbers that are generated from this. So we did what an array function does. We broke it out so you can see it arithmetically. And then we use the function to show you that they equate and are actually equal. So I'm not making stuff up. This is how it works. And then we're putting the pudding out here so you guys can see the proof. But yeah, if you want to take a look at that, by all means, pause the video, run through understanding it a little bit more if you want to. This is just kind of on the data side. If you understand how it operates and when to use it, that's fine. That's all you need to know. Why would I use it? What does it show me? How do I use it? Why is it powerful? If you want to understand the working side to it, then even better. All right, let's jump back to our presentation. Okay, conditionals. So how conditional works, and as you can see, I'm trying to add some humor here. I'm sure you guys are just all on the floor right now, just can't control yourselves, but I wrote a conditional in the title, and so maybe you can deduce how it's structured just from the title, Otherwise, we'll get into it in literally 10 seconds. So if you is equal to be listening, then what will happen? Then I write it out there. You will learn about conditionals. Everything else, you will not be. We're just going to do nothing. We're going to return 0. Hopefully that didn't confuse you. We're just trying to have some fun there with the title slide. All right, so first off, it's logic. You have a logical expression. And what do I mean by that is every conditional has something it's comparing, it's evaluating, okay? So you're going to be taking an item and evaluate it. If it is true in that expression, then you will execute something. If it's not true, you will not execute. But it all starts with logic. You have a logical expression. So what are we comparing to what? For example, let's look at this box full of live animals. Pick one up, and if it's a cat, then do something. So our logical expression would be, is this animal a cat? Is this animal equal to a cat? Yes, it is a cat. Great. So we happen to pick up a cat. What do we do in that case? So our logical expression evaluated to being true. What do? Well, we're going to place it back into the box. So we're going to return it to where we picked it up from. Why are we doing that? Just because we told the computer, or in this case, Google Sheets, we told it that's what we want it to do. So we're telling it what to do. So you guys are writing a very small program into this cell, and you're expressing exactly what you want it to do. Okay, good stuff. Now, if our logical expression actually evaluates to being false, so say you pick up an animal out of that box full of random wild animals, hopefully you have your rabies shot, and it's not a cat, then what do? So that logical expression, is this animal a cat, is evaluating as false. So what are we going to do in this case? And you also will be writing what happens in this case. It's not just an automatic expression. There is a default if you left it blank, but in this case and all cases that we're going to look at, we're going to hard write exactly what happens if the case is false or evaluates to being false, if the logical expression is false. Okay, so in this case, if it's not a cat, awesome, put that animal in my backpack. Hopefully I have a pretty big backpack with a couple holes. Hopefully, we're not trying to do anything that PETA's going to get called on us for. That's how your logical expression works. Okay, your conditional statement. You have your logical expression, you're evaluating it. What do you do if it's true? Okay, got it. What are you doing if it's false? Okay, got it. That's all it is. So let's see that in action. Because why not? Conditionals. So what do we see here? Let's look at the data. If we can, make it a little bit bigger. Boom, boom. Okay. So once again, not too much information. We just have data here. Let's look at it. Let's interpret it really quickly. Okay, we see it says speakers, number ordered. We have some discounts over here. We're showing components. We're looking at savings. So what I'm getting at right now from the information we are seeing on the screen is that we're probably looking at a bulk order of components, from somewhere where we can get discounts on ordering in bulk, and we're going to be manufacturing elsewhere. Okay, we don't know manufacturing costs or whatnot. All we know is how much we can save by buying in bulk versus not buying in bulk. And that is all that we're calculating here, okay? So just like that, we're going to interpret what we're looking at and probably what we're going to be wanting to operate on. I'm assuming it's going to be something to do with volume discounts, and I want to volume discounts is highlighted in red. So let's take a look at it. If we buy 51 units upwards to 100, we get 20% off the cost of the component. That's good. That's pretty good. A fifth off. And then it looks like as though if we order over 100 units or 101 and up, we're getting 30% off. And being the math geniuses we are, or hopefully are, or will become, we know that 30% is more than 20%. If I can make this bigger. I don't know why it keeps jumping back and forth. 30% is larger than 20%. And so we definitely wish to be in this 30% world or 30% savings category. But remember that it also requires us to be purchasing almost 50 units more than we would need currently. Because we're hopefully saying that this number is optimized for the customers that are purchasing our products, for our price targets, etc. But you never know. Maybe it's more beneficial to plan ahead and order these parts for today's sales and for tomorrow's sales, which might be over 101. So we are going to want to dive deep into these sales and dive deep into the numbers, and that's why we have them out here so we can operate with them, understand them, and mold them into telling us something more or showing us something that we didn't know prior. Looking across, there's one more thing to note. We have our units required. It jumps up to 102 for the diaphragms, and that's you'll see that happen a lot when you're manufacturing. That units require 2 or 3 or 4x of a certain item, whereas others require a 1x. And so it looks like across the board we have the only thing required are 2x or 2 units per speaker would be the diaphragm. Okay. So with that being said, since the only thing that needs 2x is the diaphragm, we can go forward looking at the data because everything else is pretty straightforward. So let's open this up here. And we see very clearly that there's a sort of a conditional statement wrapped in here. There's an and statement that I haven't even looked at with you guys yet, so don't worry, I'll explain that. But all of that crammed into there, when you hit enter, it's returning that beautiful $1.40, something very simple. So let's look at this diaphragm column one more time, because it's written slightly differently. So are the following components that follow after it. So we have our if statement starting off, and our logical expression being units, so 100. Is it less than 51? And you guys might have seen this number jump to 100. That's because I altered it. I wanted to give you this example first, and then we'll shift back to 51. But units at 100, is it less than 51? No, it's not. Okay. So this 0 is only going to be expressed if this is true. And this logical expression is evaluating to false. So we're not going to do this. So now what do we do if false? Well, we're going to run another if statement. Okay. So if this logical expression, units is greater than 100, is true? No, it's not. Then run this, but it's not true. So what are we going to do? We're going to do the false expression, which is diaphragm cost multiplied by $D, $3, or the absolute reference to D3, which is right there, 20% off. And that's what we want, because 51 to 100, that's what we have right there, 51 to 100, multiplied by 20%. So great. Take it. What $12 multiplied by 0.2. That's going to show us our volume discount. Okay, return it. Perfect. Let's look at one more time really quickly just to read through it. If B2, our units, is less than 51, which it's not, then do nothing or return 0. If B2 is greater than 100, which it's not, then do this. We're not going to do it because that's the true statement. So we want to run the false statement that's associated with this. And the false statement is D5 times D3. So D5 times D3. So D5 is the cost of wiring. And wiring times D3 is 20% off. So that's going to give us the volume discount of our wiring. So nothing crazy there. Now going over to our volume discount for cabinets, this is running the if statement. And ifs, plural, is very different than if. So as you could see, we had the nested, and let's jump back over to it. We had this nested ecosystem of if statements. We had an if statement here and another if statement there. And then we could have had another if statement inside of that. And then we could have had like 60 of those. And at the very end, the trailing parentheses would have been astronomical, and it would have just looked horrendous. And so there's and it can get complicated, to keep track of all those, and it can just get error prone as you can leave one off or have too many or have something in between or be running additional equations here and want to alter one, but you don't know what branch of that nested if statement you're actually within. So, typically it's better if you need to use multiple if statements to just use ifs. And we'll see why in a second. But also in this case, I would argue that, this is fine. This is totally fine. And the reason I'd argue that is because it's quick, it's efficient. I'm not getting lost. It's just 2 nests deep, or 2 levels, or 1 additional level deep of if statements. It's manageable. 3, you could even argue is all right. You can debate that. Anything over 3, you'd really have to show me a use case where that's the most appropriate structure. It's not going to be wrong. But, if you ever have someone else needing to add to your data and then they want to alter something, they're going to be having a chat with you, so to say, because that's not very efficient structuring. And so what we want to use, what we want to use is, let's see if we can jump in there. There we go. This ifs, the plural. Love it. What it allows us to do, we look down here. I know we're jumping everywhere. You got to follow quickly. What it allows you to do is your logical expression and then just what happens when it's true. There's no false value. You're never saying anything when it's false, okay, in the ifs. You're just saying, is this the case? Yeah, it is? Okay, then do this. It's not the case? Okay, then look at something else. Is this the case? So you're giving it a case-by-case basis. It doesn't mean you can't give it an expression, and you are, but you're saying, look at this expression. Is that true? No? Then this expression. Is that true? No? Is this expression true? Is this one true? Is this one true? So that allows you then to be all within one statement or one function. And we'll see here, we jump right into an if statement. Is our units greater than 100? No. So we're not even looking at the true value here. We're looking at our next condition. And we see our first instance of an and function. And so and is very simple to understand. It's 2 logical expressions and they both have to be true. So that's where the and component comes from. It's logical expression 1 is true and logical expression 2 is true. Okay, if both are true, then great. We're going to return a true value, which then would say to this if statement, it's true. And since it's true, run the true component or the true value that's associated with it, which would be D3 times B5 in this case, which is the discount associated with being between this range of 51 and 100. Hopefully that's not too confusing. One more time, an and statement just needs both of its logical expressions to be true. If one is false or they're both false, then it's going to be false. Simple as that. They both have to be true. And from this, you could probably deduce that there's also an or function, which you might use sometimes, which would be this logical expression 1 or logical expression 2 need to be true. One or the other needs to be true. If they're both true, that's also true in an or statement. Don't quote me on that. Double check me on that. I'm pretty positive that's the case. But for sure, it's one or the other. Very good. So in this case, we have units at 100. So we're going to go through here, and our statement's going to read, is units equal to 100? No, because this is saying it has to be greater than, so we're not doing this. Are both of these the case? Is it less than or equal to 100? Yeah, it is. Is it greater than or equal to 51? Yeah, it is. So we're going to do this. So that's what we're doing in this case. We're doing D3, which is the price of cabinets, so we're multiplying against B5. Sorry. We're doing B5, which is the price of components of our cabinets, and then we're multiplying it against D3, which is our discount rate for that units ordered, for those units ordered, that volume. So you can think of it as your volume discount. Very good. So let's make sure that it jumps around and expresses itself correctly. So we change that to 50. All of these hit 0 because there's no discount given. That's correct. Let's check it as 0. Okay, let's check it at -10. I don't know what -10 units ordered would look like. Let's say it's your returning units. Okay, let's look at 500. So you can test like this, but you don't need to really. It's more so looking at your operations, your functions, and making sure it makes sense, and then maybe a couple tests just to prove that everything's in working condition here. So let's look at what else do we have? 100. So sometimes it's worth looking at the breakpoints, so at the endpoints here, as far as in the conditions. So 51, 100, 101. If everything changes, let's see what happens at 101. Everything changed appropriately. Very good. All right. Count if. That's something that's worth covering. So we have equal count. And all that's going to do, let's look at a range here. I'm going to highlight this range. And that's just going to return the actual count of the cells. Okay, so that's returning 7. That might be important. We also have count if. And so what that's going to do, and if you ever, I know the first time presenting this, I forgot the difference from Excel and Sheets here. But if you click this little help icon, you can see the structure of it is the range first and then your criteria. Okay, and it looks as though the criteria needs to be in parentheses here to be evaluated correctly. Yeah, so let's do a quick example. We have that range. Let's look at the same range right there. No, actually, let's look at this range. I want to see which components or how many cost more than, let's see, cost more than $7. How many cost more than 7? There's 2 components that cost more than 7. Okay, so right away I know that 60% of the components cost less than 7 or $7, and only 2 are over that. So maybe I work on figuring out which 2 those are and decreasing the prices of those. It doesn't tell me too much. It's just basic information right now, but we're trying to cover it so you understand what you could utilize these expressions and functions for. All right, let's jump back. I think we covered that, to its fullness. There's nothing really else that we could do there. The lottery model. All right, so you guys are hosting a lottery. You're raising money. You're selling those tickets, those little stub tickets, and you're going to pull one out. There's different colors that you can sell. A company is offering to back the payout so you guys, don't end up like losing anything, but they're going to take 70% of the proceeds. And so you want to understand, should you take this offer from them? Is there any risk to you guys from running a lottery? And so, well, typically there wouldn't be a risk, but let's look at how you guys decide to set up this lottery. And how it works is you're selling red, blue, green, yellow, pink tickets, and they're all associated with different payouts. And so when we look at this, we see that the red ones cost $5. They return 10 if you win. The blue, $10 it costs, and it returns 20 if the people win. 15 for any of the green tickets, and it returns 30, and so forth and so forth. And how it would operate is you're selling 1,000. Let's make this a little bigger. You're selling 1,000 red tickets. You've sold 1,000 red tickets. And so if you pull one red ticket, everyone with a red ticket wins $10. Now remember that 1,000 red tickets that you sold means that you raked in or you took in $5 times 1,000. So do that quick math. I'll give you guys 30 minutes. No, it's $5,000 you brought in. So kudos to you guys, 5,000 you brought in, but now you're gonna have to pay 10,000. So if that was it, if you only just sold 1,000 red tickets, you guys just lost $5,000, and I mean this doesn't make any sense. But what you also did was you sold 500 blue tickets, you sold 100 green tickets, you sold 50 yellow tickets, you sold 10 pink tickets, and these have different payouts. These are $20 that the blue tickets payout cost 10. We went through this. So you can see these have 2x multipliers on the returns for the cost. Now the yellow and the pink have a 3x multiplier. $50 invested, you could win 150 potential. So the potential here is a 3x return. Now you have to notate that, or take down here that you've only sold 50. So the odds of actually pulling a yellow ticket is 50 out of the total, which is 1,660. So you have 50 over 1,660. What you can see is actually, as highlighted in this cell, 3.01%. So the likelihood of this event occurring is 3.01%. How do we calculate that? Took the exact same cell references we just spoke about. 50 is the quantity of yellow tickets we sold over the total. Very simple math, but if you wanted to see it broken out, there it is. Let's make it a little bit bigger so you guys can look at these numbers. Here we go. Big, bold, right in your face. Okay, learning, absorbing it all. Can't ignore it. Looking across the likelihood of getting a pink ticket. Remember, in this event, what happens? You guys end up owing $3,000. But what's the profit? You guys net $12,000. Now walk through this. If this is the potential payout, this row right here, this is the potential payout or the cost to us. It's $3,000 if we pull a pink ticket. That means that there's 10 people that bought this at $100. So we take in, signified by this or this cell right here, $1,000. We take in $1,000. Now we have to pay, what is it? $3,000. So there's the cost to us. Cost us $3,000. So we pay out $3,000. We take in $1,000. What do we net from just the pinks alone? We net $2,000. Sorry. We lose $2,000. So net profit from just the pink is negative $2,000. But now remember, all of the revenue generated from everything else, we actually make zero payout. So this is all revenue. This is pure revenue. This is net revenue right here for those individual columns, okay? So it's going to be the negative 2,000 plus 2,500 plus 1,500 plus 5,000 plus 5,000. And so in totality, in aggregate, that's $12,000 that we net. Pretty good, right? So the total, and what we did over here was used a sum product. We took C2 through G2, so the cost. And what did we multiply against? Or what's our other array? The quantity sold. So what happened is we took C2, we multiplied it to the quantity sold. We then took D2, multiplied it to the quantity sold, so forth, and then added those all together to get our total revenue. From total revenue, all we do is subtract the actual cost, which is the 3,000, and we get our profit. 15,000 minus the 7,500, 7,500. Okay, so there is a benefit of using Sumproduct. But actually what I do here is I use instead of calculating from Sumproduct, is I wrote a specific function for the use case in this example. My net profit equation here, or the function I use, is proprietary. It's just specific. I wrote it myself for this. But obviously there's many ways to go about solving this. So don't worry about that. We'll talk about writing custom functions later. It gets into more slightly more advanced, but not too crazy of Excel functions and functionality. So don't worry about it right now though. But actually what I do here is I use instead of calculating from Sumproduct, is I wrote a specific function for the use case in this example. My net profit equation here, or the function I use, is proprietary. It's just specific. I wrote it myself for this. But obviously there's many ways to go about solving this. So don't worry about that. We'll talk about writing custom functions later. It gets into more slightly more advanced, but not too crazy of Excel functions and functionality. So don't worry about it right now though. Let's see, what else are we looking at? Expected value. So if we expected value, yeah. So if we look at running this lottery, there's a couple of instances where we make a profit. In fact, in all these scenarios, we make a profit. We see here red 5,000, 5,000 blue, 12,000 green, 7,500 yellow, 12,000 pink. So every single scenario, whatever we draw, holding these values of quantity sold and these payouts and costs constant, we're making money. Now our expected value is saying, if we ran this, thousands of times, what is the average likelihood of the payout? If we average those, what are we per time that we run this exact scenario? What is our average payout, our total profit? And so we can see over here in this square, the total expected profit or expected value of running
this scenario is going to be $5,539. And so all we did was we took the percent probability of pulling a certain colored lottery ticket and multiplied it by the net payoff or the net profit in that scenario. Okay, so that gives us our expected value for that specific outcome within this lottery. Okay, now we do that for all of the probabilities and all the outcomes, and we get our completed expected value of profit. Okay, or EV. So our expected value playing this lottery is 5,539. So we are not going to play. Sorry, we are going to host, and we are going to put this scenario towards the public. As long as we hit these sales numbers, we're going to be making some change here, and we're going to be having a nice little weekend. Or maybe we're investing this and compounding our actual profitability. Another way to look at this is saying if 75% of this is going to be taken, let's just do it very rudimentary. 0.75 times this, $4,154 would be paid out to the company that's sponsoring or willing to take on the payments for this lottery, leaving us with the difference between the two as far as expected payout or expected. So we would have 1,385. Now, are we willing to pay that 4,154? Now, obviously, it's going to be more. Remember, in any of these outcomes, this is going to be 75% of these values. And this is the expected value percentage, not the percentage of what we would actually end up paying. Think of it if we had just ran it once and we pulled, a red ticket. Well, it'd be 75% of this. So very quickly, that adds up $3,750, just like that. So it's not going to be this number here. That's all I was trying to get across. So it is pretty interesting to look at it. So you would be asking yourself, are we willing to pay $4,154 for what? Are we getting any kind of insurance? No, there's not a single possibility where we lose money. Maybe we don't know for certain if we're going to hit these sales, but you're taking it as a given that you are going to. And with that in mind, and obviously that's not true. You don't know you're going to hit those sales. You don't know you're going to have 10 pink tickets sold at $100 each. You just don't know that. But with that being said, in that case, you wouldn't do that deal at 75% of profit. Does that make sense? Hopefully it does. And if it doesn't, replay this or construct it yourself and take a look at it, play around with the numbers. But yeah. So now, scrolling down, we're going to take a look at what happens in this case where we have the same game but slightly different. One, there's a slightly different structure, and two, there's slightly different amount of tickets sold. Now, in this first scenario, it's the same amount of tickets sold. But what has been introduced is the sales cost. So right here, this row 29 and this row 27 are brand new. So the promotion cost per ticket sold means it's costing us about $2 to have someone go out, find, promotional activity, whatever it is, to find someone who's going to pay $5 to buy a red ticket. Okay. Same here. In order to get a blue ticket sold, it's costing us about $3 in marketing to get that sold. Okay. About $4 here to get that sold, about $7 here to get one sold, and it's about $50 here to get one sold for the pinks. So in total, to get one pink ticket sold, it's costing us $50. All right. So now looking at this, the sales cost is $2,000. We have $2 times 1,000 of quantity. So we broke that out into its own line item. So that's new. And then we have a total sales cost. Potential payout, you guys can read through this and sort of understand it as well. But the potential payout only changes as a factor of the sales cost, okay? So if you look up here where we have the same quantity sold, the only difference is this additional sales cost. So 10,000 plus the 1,250, or subtract it if you want to, is 11,250. So that's the only significant change we introduced here. Net profit, still calculating it the same way. Our net profit in this case is 1,000. Net profit here, 2,500. Net profit in this scenario, 11,200, 6,800, so and 11,000. So really, there's still not a single outcome where we lose money. So we also would not take the deal with the company to sponsor the actual the actual payout. So we don't need someone to cover the payouts. We don't need any insurance, so to say. It would be unnecessary. We would just be losing money off the top of a guaranteed, expected value of $2,301. Very good. Let's see, is there anything else we're missing here? That's pretty much it. Now let's look at a case. Let's think, this structure is known. We know the probabilities, we know the payouts, and we know that this lottery is live, that we want to play in it. This has actually happened before. There's structures like this where most people are willing to buy these cheaper ones, so it offsets the few people that are going to be dumping money onto these higher ends, which is just a money drain as far as you have the majority of participants on these lower end, increasing the difficulty of hitting the odds on the higher end. And actually, up until even recently, I think the last time the lottery got gained for setting up a structure like this was maybe 10 years ago. But you guys have Google look into it. They're pretty interesting tales. But you can tell really quickly that if you just shift the probability of being heavy in the low end, where the majority of the odds are stacked against you, and flipping that to having where everyone's basically investing in these top tiers here, or even collaborate and communicate efficiently where everyone's dumping into one category, even if it's any of these really, then you're guaranteed a benefit beyond your initial investment. So you're guaranteed a return on investment greater than the initial capital up front. So with that being said, let's take a look at how we would game this. So just like I said, everyone's colluding. No one's paying into these amounts here. And they're all going for the $1,000, or sorry, the $100 and the $50 tickets. So with that being said, what would happen here? Well, you would end up with an expected value loss of negative $132,000. So not a great day for you to be a lottery hosting this game. And in fact, this is a case where that 75% off the top of profit as far as your expense goes with that company's sponsorship would be greatly needed and greatly beneficial to you. It almost act as it would be insurance. You'd end up paying nothing. They would incur a $132,000 loss. All of the people who were in the community who bought into this lottery made a bunch of cash and then left. So everyone's happy here except you. I mean, you're not mad. You walked away without anything, but you're okay. You live to fight another day. And then the insurance company, so to say, is taking a big hit. Now, you could even skew this even more so and have everyone buying the 1,000. The max is 1,000. So if you notice that nothing's going over 1,000, you only have 1,000 of each color that you can sell. So yeah, that's kind of the no good zone. But that is when you would definitely want the insurance company to come. Okay, let's take a look at how you can maximize your profit as a lottery company. So in this case, what you would want to do is have an optimization strategy. And really what you want to do is to max out all the tickets bought, right? You want to max out all the tickets and then optimize the pink or the most expensive ones to you. Now, the pink and the yellow, you could think about optimizing, but really it would be keeping this number is what you optimize. And you can even run it through the calculations yourself and find out that, yes, you would keep yellow at 1,000. Anyways, with proper optimization, you would see that the expected value is $57,023. So you might be saying to yourself, okay, I don't need insurance. But really, you're saying that on average, you're willing to pay about $57,022. worth of insurance cost to that company. Now that's not going to be 75% of these net profits. In these cases, it wouldn't be. In these cases, you'd be covering your backside. But remember, if you're saying I'm going to pay a lump sum, $57,022, and you're just covering this outcome or you're covering these outcomes, that's a lost profit. Here it's complete. It's a complete loss. There's no profit for you. There's nothing left. And here it's a complete loss for you as well. But you do protect yourself from losing an additional amount over the initial investment. So really here you have a loss. This is the only case where you really have a true loss. But I'm seeing if there's anything else that we should add here, but there's really not too much. So as far as taking the insurance goes, 75% of net profit, that would cover you here without any cost. If it was a lump sum up front as far as insurance payment went, then you could say some factor of expected value would be proper. $57,023. That just doesn't make sense for these numbers, but you can actually calculate the optimal insurance payout to cover this as well. But net profitability, and when we factor into expected value, if you really truly did optimize this and incentivize people to go out and sell these tickets and hit these constraints every time you ran this game, you would be looking at making $57,023. So not a bad day's of work. All right, and that, without anything else to add, is going to be wrapping up today's modeling lecture 2, ins and outs of Excel. We introduced functions, statistical functions. We did A to Z of all the beginnings of proper Excel or sheets use. We looked at proper structuring of conditional statements. We looked at the differences between if and ifs. So you guys learned a bunch. Trust me, 50 minutes. If you didn't learn something, then I'm sorry for wasting your time. But truly, we went over a lot. So I don't know what happened to you. Hopefully you learned something. What I'm going to do now is I'm going to jump straight into making and releasing the next video, which is just going to be very, 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 very quick. 5-10 minutes tops, about kind of a quick recap on this video, but then really just focusing on what's needed in order to do the assigned work that goes along with this series. If you are following along with that, great. That next video is going to be really what you're going to want to pay attention to. All of the material covered in this video that we just spent 50 minutes on is necessary, and it's going to help you, in all of your Excel journeys. But the core concepts needed for the assignment that's going to be released soon is going to be described in the next video. I swear, 5-10 minutes.